Hi, folks, and welcome to challenge 8 of 65 of my TypeScript challenges. So every new challenge I do, I just end up being surprised by some subtle syntax in TypeScript that unless I actually read through every single line in the documentation, I'm sure I wouldn't catch. So I think Infer is one of those. I don't remember Dan Vanderkam talking a lot about it in his book, Effective TypeScript. So I'm not that familiar with it, but it seems like it's what we needed or what we needed for yesterday's challenge, which is what I'm going through right now. Challenge 7. So yesterday I struggled with this for like maybe 40, no, maybe much, it felt like much longer. And I just stopped and looked at the answer because I wanted to watch my K drama, Business Proposals, which, by the way, was lit yesterday. Oh my God, the way that guy was treating his girlfriend, you guys should watch it. All right. And I looked at the answer for this because I had just spent way too much time, but I'm going to try and go over it again today. And hopefully I understand it more fully today, although I haven't had a look at it since yesterday. So just to refresh, given this kind of promise type, we'll want to return the inner type. So here we want to return string, here we want to return field, an object which has a property field of type number. Here one returns the union of string and number. And we have our tests. Cool. And so the idea that I was going with was um the idea I was going with yesterday was to use some check. If it's successful, return, basically check if it's a promise. Let's just comment this out. Check if it's promise. If it is, recurse on my awaited with a promise type. Otherwise, return the type if it's not a promise. And I got stuck. I got stuck because I didn't know how to check if something was a promise. I don't think I remember from the solution I looked at how that was done. But yeah, we do want to take something that is a promise. That extends, and this is what I tried to do yesterday. I tried to simply do extend a promise. But yeah, you can see it says I can't do that. T is declared, but its value is never read. Generic type requires one type argument. And then went down a rabbit hole, giving this the type of unknown. I think I could have also done something like type 8. Nope. Unknown, because I don't know what type we're expecting. And somehow I didn't want to access unknown. Check if unknown. Check if unknown is a promise. And if it is a promise, return my awaited unknown. Else just return unknown. That's the basic idea. And I just want to, and yeah, I'm stuck again because I, hmm, I don't know how to, because I don't know how to get, I don't know how to get this as a parameter type, this unknown value as a parameter type. And I only glanced at the solutions yesterday, so nothing's coming to mind. In which case, I think I'm going to have a look at the solution, and this time, not just glance at it, but understand how it is that they're getting this type U as a parameter type. Let's see. Let's see. We have T, which is some sort of promise, it extends a promise. I know from one of the solutions I said that the main thing here is how I'm checking whether I'm getting a promise or not. I can't just do this. Yeah, I can't. I don't know. I really don't know. So let's have a look at the solution that's here. I think as of yesterday, I preferred that. I mean, that's doable, but let's look at this one. Yeah, so this is more like the exact structure I was going for. And what's interesting here is he is allowing like a super broad type as a parameter, and then checking, which makes sense. You're not checking the type, whether the type is a promise at the parameter level. You're checking at the logic level of the generic type you're implementing. Now, this is the second thing that aside doing this check in the body of the type, this is the second thing that's important to me. So I was trying to figure out how to get the passed in parameter as a variable, like a parameter type, right? And this is being done using infer. Okay. So two things I'm curious about are, can we do this here at the parameter level of the generic type we're creating? Yeah. And also the second thing is, what exactly is infer? So let's check what we can and cannot do with infer. So let's say we infer R right from this point. We cannot do that. And I'm curious why. Infer declarations are only permitted in the extends clause of a conditional type. So, I mean, that's a quick answer to my first question, and I understand better now why that response opted for for using infer in the body of a conditional. The next thing is, what exactly is infer? I wonder if we can pick the definition. There's no definition, right? So what we're going to do is look it up. There's an article on it, but first of all, I just prefer documentation. Right, so keyword infer. Type inference in conditional types. Alright, so within the extends clause of a conditional type, it is now possible to have infer declarations that introduce a type variable to be inferred. I'm not quite sure what that means. Such inferred type variables may be referenced in the true branch of the conditional type. It is possible to have multiple infer locations for the same type variable. For example, the following extracts the return type of a function type. Type return type takes t, gets the value t extends, a function type that takes args of type any array, and returns infer r. We take the return value of r of this function type in the truthy case, otherwise we return any. That's nifty because I think that's exactly what I wanted. Like all these parameter types that are being passed in and parameter types that are being returned, a way to get access to them to return them as like what they are rather than unknown or any. And the key thing for me here is it's not possible to have infer declarations that introduce a type variable to be inferred. I'm just looking at this. What else is here? Okay. If you asked me to implement infer on my own, I still wouldn't be able to. I'm pretty sure it's going to come up in one of the more difficult challenges. Let's check. Um, Infer. Oh, well, if it comes up, it's not named infer. Um, so maybe it's more like a type of thing, right? You wouldn't expect to be able to implement type of. What is this? So I'm curious what this page. This is all the way from 2.8. Okay. What did we call it? Declaration. They called it a declaration. Mhm. Okay, so now that we have access to our inferred parameter, we can simply use that. And no, if t extends a promise, otherwise, that's not what we want to do. This is what I wanted to do. Now I'm worried that because we're going to be using the inferred r in the negative case, it may not work. Yeah, as much. Because yeah, the doc said we can only use it in the positive case. And isn't this what I wanted to do? If t is a promise of some sort. Oh no, I want to return. If t is a promise, I want to return. Oh, well, I do have like fish memory because yeah, it's right here. I did want to say if whatever is a promise recurse on whatever it is. I did want to recurse on t. I'm just curious what happens if I do that in the faulty case. Okay. Um doesn't work. It's not the logic I was going for and it doesn't work. I'm glad about that. So is that solution that we saw really correct? If you go into our weighthead and we look at the solutions, and we look at the thirds, I think it was this one. That's very interesting. If T is a subset of a promise type that takes in some type R, then we recurse on R. Oh yes, of course, until T is not. Okay, yeah. So I was completely wrong with my logic. Maybe this is why I had such an issue yesterday. Cause I was looking at it all wrong. So if unknown is a promise type, I was gonna recurse on It's so similar. If it's not a promise, oh yeah. If it's if but the things I was using you. Why did I make this mistake? That's interesting. All right, so let's look at other ways this was solved. Um, let's look at let's look at this one, the one that was using. Yeah, so they do a check. I think this check is important actually because again, no. Let's the first solution took t, checked if t was a subset of promise, and we inferred the parameter that promise was taken in. And if it wasn't, then we did want to return t. If it was, we wanted to recurse on r. Now the problem with this solution, yeah, is that it's not complete. It's not complete because this squiggly line should not be here. It should be flat, saying indicating that an error was thrown when we tried to pass in a number. So what that means is type check. Let's check my weighted with number, right? It should throw an error because 5 is not a promise type. It's not a weighted type. This generic type should only work on types that are weighted types. So this solution is incomplete. And I'm glad because that's why I started my solution. And I'm sure that's why this person starts the solution as well with t extends a promise type unknown, right? And so that fixes this error. Well, does it really? It seems like everything's messed up here. But this is good. This tells us, as we should have, that we can pass in 5, a type 5, or a type anything that's not a promise, really, right? You or some object or anything that's not wrapped in promise, we can pass in, unless it's wrapped in a promise like this, we can pass it in. So that's good. Next thing I'm curious about is how do we fix this issue where it's telling us that R does not satisfy the constraint? First thing, like my gut instinct here is to try and constrain what our infer type is, right? So let's infer that to be of type unknown. We can't. I'm curious why we can't do that. It thinks I'm trying to make a conditional statement. Okay. Infer R extends promise of type unknown, do something or otherwise do something else. And here it says type R does not satisfy. So even trying to extend, interesting. So, I mean, why can't I just do that, right? Otherwise, R. Otherwise, R. Cannot find name R because this is in the falsy case of our conditional. And this is still telling us that R does not satisfy the constraint promise unknown. So I'm just going to backtrack now before it's too late. Backtrack. Oh, well, there's something wrong here. There's something wrong with my syntax, isn't there? There it is. Another thing that seems fishy about this is when you use a conditional, you're returning a type, and it's unclear to me at this point whether we can return a type to an inferred parameter. Like it's meant to infer it, isn't it? Um, so I guess I'll read that article to understand a bit more about what happens when we're inferring stuff. Okay, cool. We can't find R, again, it's in the falsy case, and R does not satisfy the constraint. Um, if R does not extend, is not of type promise. So what exactly, just taking us a couple of steps back, let's think of what exactly we want to do. Just gonna think of what exactly I want to do. Um, yeah, keeping in mind that I can infer, I now have the power to infer a parameter that's passed in. Let's see what I can do starting from this point that I started out yesterday. First of all, okay, if t, if we get t as it is right now, and given we can't infer the parameter in without using a conditional, something that's popping in my head, can we use a conditional in this parameter block scope, and will that help us? Let's try not to. That solution we picked at didn't quite use that, so let's try and implement this without relying on that. Seems like we're back to square one though, because if t extends a promise, then we know it's a promise. If we know it's a promise, we know we want to recurse straight away on t, unless I see. We want to try and recurse straight away on t, but if we can't recurse straight away on t, then we want to return. No, that doesn't make sense. T is definitely a promise. We do still need some way to get access. Um, to get access to. I'm confused. I'm not confused because what's wrong with just combining? So we have T. We know it's a promise, and if T extends the promise that we know it is, and then we infer in the actual body of the type, um, the parameter that's being passed into T, then what's wrong with doing exactly what we did before? Like, oh yeah, oh my god, I have fish memory. We just did that. We just googled that. Okay, so I clearly didn't appreciate what this error meant, and I think the way forward is to try and understand this error and fix this error. It's saying that R does not satisfy the constraint promise unknown. So what I'm just trying to do here is to tell the to tell TypeScript that I know better than it. I know that R does satisfy this constraint. But the more I look at it, the less it makes sense because this is repetition. Doesn't make this doesn't make sense. I don't know that R satisfies the constraints. This double check. I wish there was some way we could be more precise. We know T is a promise, so checking if the promise again is like it's redundant, right? We will never get something that's not a promise, that's not wrapped in a promise. So can we do my awaited R? My awaited. We can't get access. We cannot get access to that parameter that's being passed into T. We just can't. And even if I try to do a my awaited, there is no syntax I know how to check if my awaited throws an error or not in TypeScript. So again, let's pick up the solution. T extends a promise infer X. If X extends a promise of type unknown, brilliant. I mean, brilliant. This person clearly just went through with their thought process. Yes, we know T extends a promise of type unknown, but now we know we extend the promise of, and we have access to the type that's being passed in. And let's check if that type that's being passed in extends the promise of unknown. And if it does, let's recurse on my awaited. If it doesn't, let's return X. Otherwise, we know we're never going to get here because we know already that T extends the type of promise unknown. Yeah, this is, I mean, you know how it is when this sucks because, I mean, I'm just going to learn from it, right? What else can I do? This sucks. It sucks that I couldn't figure out how to address that error we're having. We pretty much stopped here, didn't we? And the idea was to go straight into the recursion and check if, and, and basically do that. First of all, we should not even have access to X here, right? That's the that's the false case. So that was the first hint. Second hint was does not satisfy the constraint promise unknown. And of course, I tried to do that to enforce that constraint in this conditional. But he told me, but then, promise of type unknown. But then this prompted for a conditional, right? And which should have hinted at me, giving me the hint that I really should not be trying to do this conditional in here. Although I'm not sure that I can't. I'm really not sure that I can't. But yeah, I love that that person went with the flow, removed this from there, did that conditional there. Um, I'm glad I tried to do this on my own because something's fishy. And the thing that's fishy is that we're able to access X in the falsy case. We're able to access no. Not necessarily. This is still the truthy case of, yeah, this is still the truthy case um, of this entire, of this first conditional, even though it's the falsy case of the subconditional, which is interesting. I mean, that's something to note. I guess the next thing I'm gonna try and do is enforce all of this. I was gonna, yeah, see if we can enforce all of this in here. But from just taking a couple of steps back, what's the result of me trying to do that? At best, it's that I return X, I return all the nested promises until the last promise and get that value and just return it as a promise to this type X, from which I can potentially um, just return X, but just return X. But that would mean me returning X in the falsy case, because say X ends up being a string, so T will still extend a promise that takes a string potentially, and I will be saying if it's if T is a promise, it takes a string X, then what? Yeah, then yeah, then recurse on X. Recursing on X will not even pass this condition. Well, the other condition, we will never be able to get there because T is never going to be not a promise. So that wouldn't work. Curious to see what other ways people solve this still. So we learned from this that um, we should try and enforce type narrowing outside of the parameter scope. That's my main takeaway from this solution. Let's look at other ways this was solved. Just randomly looking. Oh, I don't need to click into them, do I? Okay, cool. This is another incomplete solution from the looks of it. The extends promise infer p. Yeah, incomplete, incomplete, incomplete. Seems like the exact same thing. I don't think this works. You can't just extend a promise. Exact same thing from the looks of it. Let's open this actually. Yeah, same thing. It doesn't look like. Why are they submitting this? Why is this submitted? Yeah, incomplete. I wonder if all these people who submitted these problems know that their solutions are incomplete. I'm not gonna bother commenting on any of them, to be honest. So many of them. This won't work. So you can't extend a promise because a promise expects a single argument. Um, mm, hmm Yeah. So there isn't. Oh, this looks new. This looks novel. T extends. Ooh, well, hmm. You're checking if T extends a string or an object. Okay, so I guess that's the way to limit. Man, no, this doesn't work. This does not work. I mean, it's close, but it's very close-minded in my opinion, because could easily just add a test case here um, for string, and that would create a squiggly line. Oh, it doesn't. Interesting. Errors. Yeah. So the issue was I was using. Yeah, that would create a squiggly line because we expect to throw an error if we try to pass in a string. Basically, if we try to pass in anything that's not wrapped in a promise, and this doesn't quite get the idea, right? That you need to extend a promise. You don't know what the promise is going to accept, but you're going to go and get that later on in the body of your generic types. I don't think we're going to see, unless we really look through, I don't think we're going to see any novel solutions except, what's this as a tick? Close issue? Hmm. Mm, yeah, incomplete, complete. Shema Shiho. Okay. Mm, mm,我的中文还有不好，我不明白这是词什么。Anyway, um, oh, so many people from China. All right. I think that's the. I think I've learned as much as I can from question from challenge 7. I'm gonna move on to challenge 8. And hopefully we can finish that within the hour. This has been the longest ever, but also it's been like the first challenge where I really had difficulty. So let's go on to challenge 8. If I mean, isn't if just a conditional? So let's go into the challenge before I read it, before I try to understand what we're going to be doing. As usual, let's check the errors loads. Yep, cool. And it says implement a utils if which accepts condition C, a truthy return type T, okay, and a false return type F. C is expected to be either true or false, while T and F can be any type. Let's see what that means. Type A, if true, A, B, expect to be A. Type B, if false, A, B. Okay, so if the condition is true, return the first one. If condition is false, return the second one. That's basically the condition, the ternary operator, isn't it? So hopefully this is an actually easy one. Let's just read it again, see that we understand. Or let's look at the test cases to see that we understand. If the condition is true, yeah, return the first one. If the condition is false, return the second one. Um, throw an error if there's no condition. Throw an error if there's no condition. Um, what can we do to enforce that we want to receive a condition? Can you assign null to unknown? So I was about to just make sure it's a subset of unknown. We don't know the condition, right? But what if you can assign null to unknown? I mean, that sounds like you. It sounds like you can type unknown, type t unknown. Let's see if t can get null. Gosh, I get so confused working in the type of value space. What I'm trying to do here is no create another type n gets value null. So some value the tester of type t. Let that get n. Can we do that? No, we can't do that. Let's just go straight to null. Okay, yeah, you can assign null to unknown. So we're not gonna if it has to be something, what's the broadest type that's if it has to be some you definitely if you can assign null to unknown, then you probably can assign null to any here type any type unknown. Okay. We can't assign unknown to any, but that's irrelevant. If we try to extend an object, that leaves out string, that leaves out number, that leaves out, what else that leaves out? Boolean, it leaves out a lot, right? How about how about we just check that it's not null, it's not undefined. That's the broadest type that I know of that's not any. Yeah, if we try to use any or none, we'll still get error, but that's the broadest type. A more specific is not, and this is all the way from challenge one. There is a way to check if something is not is not null. Yeah. Let's see if I can remember how to write that actually. Type is not null. Takes a type k, and basically, what do we want to do? We want to. It's not any rather. Yeah, that was an is not any. But we can do k extends null. I just realized checking if it's not null doesn't really help us. But we can do if it extends null, then true. If it doesn't, then false. Um, yeah, this doesn't really help us from a parameter perspective because this returns a boolean. Well, we don't want to try and do checks on C outside the parameter perspective, so I'm gonna go with this check I'm doing here. It's a really broad type that includes, I believe that includes, hmm, I'm curious. True, false. Oh, oh, come on, those. It's so obvious that the only thing we want here is true or false, or the type that results to true or false. That should have been easier to see, right? Uh, so cool. Not cool. This tells us that we can pass null to true or false. Amazing. But we shouldn't be able to pass null to boolean. Wow, we can. So, that's interesting. So, oh no, maybe that's not why. There we go. I was so confused for a moment there, Yeah. But yeah, what we want is boolean. And I think we should be fine. The next thing we want is yeah, so I really honestly thought that was gonna work because we have a boolean, don't we? Oops. Um, the boolean, we don't know what type it is. Now we know what type it is. Then we want the true case or we want the false case. Yeah, that was more like an easy problem compared to yesterday's. Um, cool. I just wonder about this null. Can I pass in something like string? All these seem to evaluate to truthy. Oh no, apparently I can't. Because if I remove this and I try to do that, I should get a squiggly line here. Does not satisfy the constraint boolean. Okay. But can I pass in something that evaluates to a boolean, like a function that returns a boolean? I don't know how to specify that. At the end of the day, this is a function that returns a boolean. I think I want to permit those. Yeah, I think I want to permit those. Although the test cases don't include that. Like, what's the difference in the type of a function that returns a boolean and a boolean? They're fundamentally different things. One is a function and one is a boolean. But if I Oh yeah, if I hmm, if I allow that, then test cases you pass in from the looks of it. Hmm, maybe I should go really broad and just accept object like I wanted to. Ooh, string is permitted as an object. No, it isn't. So I guess number will be. Hmm. This this is actually more interesting than I thought. In terms of type design from effective TypeScript, we do want to be very liberal with what we accept. That's one of the principles from type design, I remember. So I want to be as liberal as possible, but not so liberal that actually I want to be as liberal as possible, and maybe I do want to accept strings. They are truthy, aren't they? Right? So like if we get a string, we oh oh I see. I didn't catch it at first, but if this is truthy, I wanted to return A. So I want to modify the test case. And this isn't truthy per se. So the way the if is working, it's not even ah the way the equality is mm, okay. Yeah, so this was I needed to be more well it returns a boolean. I needed to be more specific. Say it returns true. I want it to be A. Hmm. So rather than just checking if C extends true, we now have to check if that's a lot of work. If C is a function that returns true, if C is a truthy value, I wonder if that's within the scope of this problem. Mm. I want to see what let's see what other people did. For now, I think what I will just for now I think I'll just revert to accepting just a boolean, checking if it's true, returning T, if it's false, returning false. Here, I think I need to modify the test. But we haven't tested the false case, so let's test the false case here. Change that to let's see what. Let's look at what our let's look at what the community decided were good solutions to this problem. See if there are any novel, the same, the same. Oh wait, this doesn't even this is incomplete because it doesn't even yeah that's redundant. Doesn't pass the null test. Yep, the same, not complete, the same, not complete. Okay, no idea. The same. So yeah, no one's really bothering to. I think official solutions to this. There should be like they did say they accept solutions to this. Mm. Let's see what the if utility utility. Okay. Um, will we find an if utility in the library? We don't. We don't. Gonna just gonna I'm gonna leave it there. I hope that 190 is open, 21 closed. Okay, cool. So we can see the, but we can't say whether it was accepted. How do you do this? In label, answer, label. We know that we're closed. Hmm. Mm-hmm. Mm-hmm. I'm only going to spend 5 more minutes on these problems. So let's see if we can find a solution. This is apparently the official solution then. I mean, as official as someone compiling solutions becomes official, this is apparently the official solution. Which looks good. I want to see what the accepted solution for awaited was. And I do like I like the branding. It gives you this like TypeScript branding, although the blue is kind of off. If you This is a lighter blue and this is a darker blue, and then stop putting cool. Um. mm, okay, so straight away I lose confidence in this repository of solutions because I can see here that the awaited solution provided here is not it's not restricting the kind of type we can pass in, which doesn't pass the test case that checks that we're only passing in promises. So yeah, so this is what I would take, something more like nope, this won't work. If we try to extend and if we try to return, wait, will it not work? Yeah, this will throw the error thing. So R does not satisfy. Oh, hmm. Well, R may not satisfy the condition of promise any. I was like, okay, wait, he did do like promise any, right? But my assumption from what I learned from that problem is when we infer R, we really don't know what R would be. So, okay, no, this doesn't work in any way because one, I should be careful not to say things I'm not sure of, right? Because it looks like, yeah, he's right. We're never going to meet this enter this condition, but there's just something that looks so wrong here. What if, right? What if R is a wrap type? What do? We just return R. We don't want to do that. So this is incomplete. Um, exactly. Wait, yeah, the next. There we go. Okay, so I'm glad the community, jumped in here, and this gives me more confidence in the solutions I get from this page. Because this is what we want to do. We want to restrict what P can be. Then we want to pick T by inferring T. Then we want to check if T extends promise of type unknown. And if it does, we want to recurse. If it doesn't, we want to return T. We're never going to get to this point, so there's no point putting a promise there, because we know that P is going to be a promise, so there's no case where P is never going to be a promise, from what I understand from that solution. But yeah, that's the wrap for me for today. It's already an hour. I don't like spending more than an hour on this. I hope, I just hope this was useful to somebody out there, and if it wasn't, it definitely has been useful to me. Yeah. Bye.